Thanks for watching our new video at the Piano Solutions Restoration Shop. And everybody knows that a lot of people involved in our business. It's just because it's a huge business, right? And we got the piano tuners, people who service the pianos. We got the people in the restoration business, a lot of other engineers and people who manufacture the piano. It's a big group of people. And of course, a lot of things depends on the experience. Like, for instance, in my case, I became a piano technician in 1972, I think. It means over 50 years I'm already in this business. Beside this last 20 years, I design a lot of tools and devices and set all the restoration process that make it easy. It's almost like a meditation. And just everything looks easy, right? You know already procedure, everything set up. But in reality, when I start to look at the certain things in the restoration process, I realize that it's a completely empty space. And of course, I try to check it in um, some books, issues for restoration. Of course, nothing. It's just like completely just like lost this subject. Anyway, there are tools that designed to perform the certain things. Like, for instance, let's say you want a straight jack on repetition and let's say repetition level itself. You want to straight it. And the only thing you can do it uh, just without major things. Or you on manufacture set really high precision process, or if they still a little bit just like miscalculate certain things, you have to adjust it. And I built this tool, what you can see it, right, that can solve this problem for you. You just use a slight like hitting on a jack, and use very fine bending of the pin, move it on the left, on the right. And that's particular thing just solve this problem, and it looks like it's a done deal. It means you know the procedure and it's okay. But if you look a little bit further, like for instance simple things like how much apply the torque on a screwdriver, and you notice that it depends on many things. Wood you're dealing with, or nowadays aluminum, you just like get a different thread on the screw. It's a very complicated matter. You can of course teach the people, but some people they got a nature or feel how to deal with the screws. But believe me, that's a lot of things happen when the technicians damage it by applying too much force. That's the first just very simple thing that just like we cannot handle it, just we don't have any research to this. Let's, for instance, look on another things, like the pads for the dampers, like for the dampers, right? And I noticed through my experience that different brands, they did it different sizes, and just like they position them differently. And that's just like bring my attention on the size of the pins, what pressure they do on the strings, what's the best way to mute them. And of course that needs a lot of research too. I of course noticed that some elder technicians at the Stanway factory, they make it different sizes, and you can follow it of course, because you kind of feel natural that they were really just skilled people, and you can do it the same way like they did it. But still, it's better if you know why they did it like this, if you ask a question for yourself. Then there are another things like friction on the flanges, right, on the center pin. Like many technicians, they just do it like by throw this shank, and they calculate amount of just like motions. They think that that's what they're looking for. But again, they can use the certain like devices, measure let's say, the friction on the flange, uh, but they don't have, or just let's say we say, I don't have it either. We don't have any tool that can help to this, like to make it consistent through the whole set. It's just on the manufacturers. We rely on the good quality of manufacturing. That's another thing. Just recently, I talked to the guy who told me that you can leave the string. Like when you string the piano, you just leave it like it is. And just let it be curved. Because when you change direction of the string, you see it's curved. And hit like I build the device or this device that's straight. Make the termination point on the string like this. I apply the force and I make this straight. But she told me that no, it's supposed to be curved, and she told it's better quality. I don't mind, just like to accept this unless it's done research. And this, what another thing that we have to do research. One is, I think, very critical thing is it's a position of the tuning pin in the pin block. Since I do a lot of pin blocks, because all pin blocks ruin, or technicians they put a bigger size that I cannot just use after later on. That's why I replace the pin block and I bore the holes for the pins on the certain angles. I made a model that show you that the pin mostly they manufacturers lean it opposite the direction of the string force, right? Like this. Now it's a common thing to do, because when the wood is kind of gets some flexibility, and when you apply the force, it move it forward. It's common sense to lean it towards the keyboard. Anyway, you can calculate how much. It might be 7 degrees, right? But again, you might ask the question, why 7 degrees? Because some old pianos, they don't have any leaning. They put it straight. And that's, you have to answer the question. Then another thing, since the string attached on the left side, of the pins. That's from your side. From my side, it's on the right side, but it's obviously from one side. Then, accordingly, geometry is going to be some force that move the pin in this direction on the left. That's why I came to conclusion that I have to bore the hole that my pin is staying some degrees on the left side, right? And of course, the question was how much, like let's say how many degrees, 1, 2, 3, or 3.5 or 4, right? Degrees, you don't know. In order to get closer to solve this problem, I built this device that as you see, it simulate the pin. It means it's like a rod, right? The pin, you can consider it like it's a metal rod that got flexibility. And I attach the thread, or in the case of piano, it's a wire, and I can apply different weights here. And by calculating the motion, like how much he just lean from the straight line, I can consider what I'm gonna do in my um, boring, how I'm gonna do boring pin block. That give me some numbers, right? But actual test supposed to be on the piano, and I bore my pin block on different angles. It depends on many things. It depends on the height of the pin. You can lean them 2 degrees, or you can lean them back and forth like 7 degrees. It's it's a lot of variables here. Another very important variable is you have to consider what kind of tuning hammer you're going to use after that. It means the angle on your tuning hammer, let's say, I can show you one of them. It's a critical too when you work on a piano. This angle, as you see, it's a critical. If it's going to be less like square, it's going to be different direction of the forces when you apply force to the handle. That's why it's critical too. When you try to solve this problem, you consider the what kind of tool you're going to use too. And of course, I did like maybe 20, maybe already 40, 40 pianos that I bought the pin blocks, and the results was amazing. The stability, the way you tune it, it was so comfortable. And I came with certain numbers. Sometimes I use the like 2 degrees lean on the left side, and 7.5 degrees towards the keys. And I did a little bit different, right? And I came to the certain numbers, like I might tell you, like 2 degrees, 3.5 degrees in the bass section. But I'm still just like be really just confident about these numbers. If somebody, like technicians in this business, do the same thing and provide me, or just like our just technicians, with this information, since we can bring together all these numbers, we can come to these just like average numbers, or maybe we just even improve it. Well, that's what my purpose is, to show you that try to solve as many things that we still don't understand how they work in the piano as possible. And of course, just there is a lot of complexity in a piano. That's why we have to challenge it together. And of course, I wish everybody good luck. Well, thanks for watching, and see you next time.